This engine is actually burning hydrogen-oxygen fuel in addition to gasoline. We're creating the hydrogen-oxygen fuel with something called a vacuum pressure fuel cell. We're going to show you how that you can make your very own vacuum pressure fuel cell for your engine and turn your car or truck into an H2O fuel hybrid. This technology works wonderfully when applied, and you can even put a solar cell on your vehicle when you're done to save you even more money as you're generating this hydrogen-oxygen gas. Almost everyone has heard the term fuel cell. However, we're not making electricity with this fuel cell, we're making combustion, because the hydrogen and oxygen gas can be mixed with our hydrocarbon fuel. This is the meat and potatoes. We're going to show you how to build this from the ground up, install it in a mason jar, mix it with the fuel we're already burning to get a much better burn from our engine. This is just water in a pickle jar, and we have a hydrogen-oxygen element, which I am going to show you how to create. Just watch this video, pay very close attention, take notes, because condiment cups are here to save the day. These are stainless steel non-magnetic cups that you can get locally, and they're going to allow you to turn your motor into a water-burning hybrid. Yes, it's true, you can get too much of a good thing, so we have created a solution to our problem of over-oxygen production. This is a flux magnetic heating tube, which we're going to rebuild for you. We're going to give you all the instructions on how to build this yourself to see amazing effects charging this hydrogen-oxygen gas electrically by polarizing it as it comes through the vacuum line from our condiment cups. These condiment cups are very inexpensive. This cell design has a tremendous amount of surface area. Now, we don't need any more gas than this right here, folks. We could easily generate 10 times this amount if we wanted to, but we just don't need it. We supercharge this gas with our paramagnetic flux line, and we have the vacuum pressure, which we're going to use to boost the efficiency of this hydrogen-oxygen production system. We're going to inject this into our vacuum system on our car, which leads to the combustion engine. It goes from the top of the jar into this line, which is going to charge this gas in the state of vacuum. So, this line is directly connected to the vacuum system of the car. It should be pretty obvious that the coils are much too close to the jar on this, and I've redesigned this, and I'm going to show you how to make it look really professional. The blue stuff that you see is far superior to anything else you could possibly use to seal your jar with, because you're going to need constant access to this. It needs to be able to come on and off. This is actually a reusable latex chemical. I'm going to show you the chemical and how to get it, where to get it. It's very inexpensive, and it's available almost anywhere. This putty that you see will actually heal itself in the state of vacuum. That is to say, all the holes that we have around our wires and around our hose will be filled momentarily after we start the vehicle and the vacuum engages. It'll suck it in, and it has enough consistency to hold. So we start the engine. You can actually see the jar pull down from vacuum. It's now sealed. We still like to take our finger and poke around on it just to be sure, but we can tell just by looking whether or not we have a vacuum leak, and I'm going to explain that because it's extremely important. You do not want a vacuum leak on your engine, because a vacuum leak will murder your mileage. Now, right now this engine is running and there are no vacuum leaks. I'm going to show you just how tough this blue stuff is. We pull it off, we try to tug around the wires to create a vacuum leak. It's still not leaking. We have about 10 or 11 inches of vacuum from the engine right now at idle, and there is no leaks from this putty. We're pulling it off, still no leaks, still no leaks. It almost looks like I'm not going to be able to get it to leak. I'm going to have to actually engage the engine to create some stress on this stuff. Tug on the wires, still no leaks. It's amazing how well this stuff works under stress from the vacuum state. I'm going to rev up the engine and see if I can spring a leak. Still nothing. Can't believe it. Wait a minute, there's the leak. This is what I wanted to show you. You can see what looks like small fluttering of the water. This is from air coming into the jar. This would murder your mileage. It would lean out the HHO gas beyond use. We must stop this vacuum leak. If you have any problems or you don't see any performance or any gains, that means you've got the leak. Vacuum leaks can cause motor missing, all kinds of problems. Dash lights, computer errors. So it's very important that you use the sealant we specify. We're going to show you how to build this thing completely. Now this is a fuse that you see on the line here. These are about $4. This coil here, about $7. And the cell element itself, which is the thing at the bottom, can be built for around $4. And around here you can get a jar complete with pickles for around $5. So this entire thing is not going to set you back a lot of money as long as you follow directions and stay on the path. If you go creating something of your own venture, you're going to spend money just like we did, and you're going to end up right back here with these condiment cups. This is a completely snapped together design that we're going to show you how to build. No secrets here. We're going to give away our best design ever. This thing produces more gas than you're going to need to turn your vehicle into a hybrid. The top and the bottom cup are the anode, that is to say the positive, and they will self-destruct over 2,000 miles. This is meant to be. This is fine. It actually adds to the pH process. We'll discuss that later. This is a jumper which connects plate number 2 and plate number 5. They will take on the negative charge, and the two in the center will be what we call neutral plates. They don't touch anything, including themselves. We do this because it saves on energy and makes the cell more efficient. This design is snapped together and can be built in just a short amount of time. Once you have this thing built, you can change out the anodes really fast. And this is important because over 2,000 miles, you're going to want to replace them. Not hard to do, and the snap together design makes it possible. No glue needed, just some time and bending. We're going to show you how to do it. So break out your needle nose and your pliers and get ready, because this is our best design ever. 3 pieces of stainless steel are used to snap the top and the bottom cups together. This gives a really good hold to the entire cell. It's going to actually squat as we build it, getting much tighter, bringing the tolerances closer together, producing even more hydrogen and oxygen gas. We solder these alligator clips to our wire connections which carry the current to the fuel cell. We do this for the best possible contact we can to the cell elements, which will be underwater at all times. The fuel cell itself will carry up to 20 amps of power during normal operation. Although it can carry even much more, we really just don't need that much. This thing is very tight and holds together very well. We could bolt this together, but we just have to replace the self-destructing positive bolts. No sense in that, when a simple alligator clip soldered on and off will do the job just fine. This putty completely replaceable. This hose line snaps in and out as needed. The putty self-healing. The connections are jumper cables which are fused. It's very important that you have your entire project fused. Everything you see runs on 12 volts, or actually about 14 volts with the engine running. In the state of vacuum, the water behaves like a refrigerant. That is to say, it absorbs energy, superheat. This energy is transferred back into the engine. When we start the engine, we get a vacuum pressure which causes an increase in the amount of hydrogen-oxygen gas our fuel cell produces. This is actually looking like I've overloaded the soda just a little bit. We use baking soda in regular plain water as an electrolyte booster. Distilled water won't even carry current at all, so we have to add something. We don't add anything except baking soda for reasons we will very soon get to. It's about a thing called pH level. Now this is a circuit breaker. It's 20 amps. We've tried others. We've ran all kinds of power. What you see here is 12 amps of electrical energy going through this circuit breaker. It protects us against a dead short, and this is very important. I'll go ahead and mention you don't want to spark that anywhere near the top of the jar. And when it's running in a state of vacuum, the concentration levels are extremely low. Explosion is almost impossible in this condition. That hydrogen-oxygen gas going down the highway in the state of vacuum is very safe because we are not in a positive pressure condition. We're not pressurizing hydrogen gas, we're depressurizing gas. This vacuum condition is what makes our hydrogen-oxygen fuel possible. You see me reversing polarity on the cell. This will actually clean the plates. The positive and negatives are now scrubbing themselves, and I do this right before I change the water, replace the water, because it cleans it out. Now these are the condiment cups that do the magic for us. You can get these just about at any food service place. They use the stainless steel because it is non-biological. These are actually just zip ties you see me using. No glue needed. As a matter of fact, don't use glue. I'll show you a much better way. Snip these off slightly above the edges of the cup. You're going to need at least 20 of these on a 6-cell cup, and I don't recommend any more than 6 cells because complex is not a good thing when you're dealing with HHO fuel cells. Matter of fact, the more complex you make it seems like, the worse your results will be and the more trouble you'll be into, as well as expense. So we start with the fuel cell, 1 cup and 4 zip ties carefully placed in the side. Now I make this look really easy, and the way I do this is by actually licking the back of the zip tie, much like a postage stamp. Don't be grossed out. You just simply set the cup in there and you're done. Then you begin the next level. Now, if you're a beginner at this, these zip ties are going to be very uncooperative. That's why you gotta have plenty of spit on the back of them, or maybe some sticky water. I don't know, but don't use glue because it'll contaminate our water when this thing reaches temperature. This fuel cell will run at temperatures near 170 degrees Fahrenheit under extreme loaded conditions. These wire ties will not melt under this condition, and this fuel cell will work even better under those high temperatures. The next level, here we go. 4 zip ties, carefully placed apart, and we continue this process on and on until we get 6 layers. Now the bottom cup is going to be a positive. The next cup up, or shall we say cup number 2 from the bottom, is going to be a negative. The cup you see me working on now is what we call a neutral cup. The neutral cups don't touch anything at all. The neutral cups are isolated by these wire ties from the other cups. They tend to take on a negative charge due to the fact that they're very close to the other polarities, which are negative. We still get a tremendous amount of gas from this effect, and we don't have to pay for the amperage. It's kind of an efficiency booster. You just slam the cup in and start on the next layer until you have all 6 layers built. Then we're going to cut some strips of stainless steel and snap these cups together, and this fuel cell will be done. It's very simple, and once you have the snaps made, you can build this, take it down, and in 5 minutes completely rebuild the cell from the ground up. Very simple, very efficient, and impossible to beat for practicality, cost, use, production. It's just simply unbeatable. Now what we're using is actually hose clamps. You can get several grades of hose clamps. This is a high-grade hose clamp, and don't buy the cheap ones. I tend to think that they're just not good. They have a lot more iron in them. We just don't need any more iron. We cut pieces, and we're going to bend these pieces into the approximate shape, and we're going to create a holding mechanism which can snap on and off as needed, as many times as needed, to replace the elements, or the top and bottom positive cups. They call these the anodes. The anodes self-destruct over 2,000 miles. It's part of the process. It also makes sure that the cups will be available in your local stores for the next 100 years. And that's important because we love these cups. It's okay to guess where to cut this thing.